covered by dialog box. Another in service process. Service process performance tasking in background without requiring user interaction. Example, playing music using Xbox, downloading file, GPS navigation running in background. Performance, save battery, power, and supporting multitasking. Each process is assigned a priority based on importance to the user. Type of Android processing stage. The first one is the foreground processing. Foreground process is process that the user is currently interacting with it. This is highest priority and the last processing documented by the Android system. Example, playing the game. Another, typing with messaging in WhatsApp, watching video on YouTube. Another type is visible processing. Visible processing is not currently in foreground, but it is still visible to the user. It's high priority because the user can still see it on screen. Example, an application that is partially covered by dialog box. Another in service process. Service process performance tasking in background without requiring user interaction. Example, playing music using Xbox, downloading file, GPS navigation running in background. Another one, background processing. Backgrounds contain activity that are not visible to the user but are kept in memory so they can be recorded quickly. Example, opening Chrome after leaving Instagram. Instagram remains the background. Okay. Another last one is empty processing. Empty processing has no active components but it's kept in memory temporarily or faster. Application startup, it has the lowest priority and is fast to be removed when memory is needed. Thank you for listening.
Assalamualaikum. My name is that's about creation and handling of process in Android. At the create everything from starting point in every time, the step as follows. First step, system will see if they have already processed application. If the process is absent or not processed, Android create a new Linux process by application. Thirdly, memory space. The space of their memory. Security, identity, virtual machine instance, and the last step, the application start execution.
Third.
Also, we'll discuss about the important process, which is zygote process. Zygote process is the important process of an Android that are used to create all process in the application into the Android container. Zygote is created only one time during Android boot. It remains to do work the system that continue to use it. Also, during creation of Zygote. Zygote created during boot of Android before user have not started to open any application. Its function of Zygote. Firstly, load the common Android library that must be approved. Secondly, maintain shared resources used by different apps. And thirdly, create new application process quickly using them. Also, we end with importance of Zygote. First, application setup and reduce memory usage. Provide fast-living response, support multitasking, protect the focus application, save battery by control background tasking, smartphone device. details mode, background execution limits, negative and optimization features. Another point, application season. Problem. Difficulty running on the main thread causes the application to stop responding. Solution. By using wake-up threads. Solution. Using wake-up threads and synchronized programming background service. Another point, security problem. A malicious application may attempt to access another application resources. Solution. Problem isolation, application sandboxing, and permission management.
Thank you so much indeed. I am Hassan Ali here. When we say CPU scheduling, this is the process of selecting which process or application should be used in the CPU whenever multiple processes are waiting. Actually, imagine that you already has different apps which are running at the same time. Example, WhatsApp, YouTube, or camera or music player. Actually, the CPU cannot execute all of them because the CPU must decide which process or which app should be to run, or which app waiting, or how long each app should be to run. So this decision is called the CPU scheduling. Also, after that, we have a round-robin scheduling. So when we say a round-robin scheduling, this is the one of the most simplest scheduling algorithm, because every process gets an equal amount of CPU time, which is called the quantum or time slice. For examples, there are different process. Example, process number 1, process number 2, and the process number 2. Actually, each process gets 2 milliseconds before moving to the next second. So this is about the round robin scheduling. Ama.
Assalamu alaikum warahmatullahi.
Ama.
To prevent interference. Second is garbage collection. Android runtime automatically remove unused memory objects. Third one, process priority system. Important application receive more resources. Fourth one is background restriction. Limit unnecessary background activities. Third one is Linux control player scheduler. This ensures fair CPU distribution. Conclusion. By conclusion, Android processing control management is designed to provide efficient multitasking while maintaining performance, security, and battery life. It uses Linux-based preemptive scheduling, priority management, and process isolation technique. Among schedule approaches, preemptive priority-based scheduling combined with completely fair scheduler is the most suitable for Android because it provides fast response and efficient resource utilization. In contrast, non-preemptive scheduling methods such as fast come, fast serve are unsuitable because they reduce responsiveness and negatively affect user experience. Through techniques such as Zygote processing, ART runtime activity managers, server and memory management system, Android is a successful control subset of process while maintaining stable mobile environments. By concluding, from those of explanation above, we use this reference.
Thank you.